Hello. This lesson is on transformations. And when we talk about transformations in a math class, what we mean is that we're moving a parent function around or maybe changing its size on the coordinate plane by using some rules that work for every function. There are three types of transformations. The first one, translations. The parent function says that stays the same shape but moves up, down, left, or right. All right, there are reflections where the parent function stays the same shape but flips over the x or y axis. And then there are stretches and shrinks. And the parent function maybe vertically stretches, it gets more narrow, or vertically shrinks, gets wider, or it might horizontally stretch, would make it get wider, or horizontally shrink, where it gets more narrow. So parent functions, you kind of need to know these parent functions. These are the three main ones that we use in 171, but all of these transformations work for any function you're given. But the first one, y equals x squared, looks like this. It has a vertex right at the origin, 0, 0. And then when you go to the right one and you put 1 in, 1 squared is 1. So you go right one, up one, and then it's symmetrical, so you go left one, up one. Okay, and then you could keep graphing, but I'm just going, plotting points, I'm just going to sketch the graph. But these first 2 points right here are important, right one, up one. So that's the x squared parent graph. And then you have y equals the absolute value of x, and that also has a vertex at 0, 0. And it's a V-shaped graph. So if you go right one, put 1 in there, absolute value of 1 is 1, you go up 1. And that also is important to pay attention to. So the parent graph of the quadratic and the absolute value. And then we have the square root function, y equals the square root of x. And that looks like this. It also has a vertex at 0, 0. And when you go right 1, square root of 1 is 1, you go up 1. So for all of these parent functions, your first movement is right 1, up 1. All right. And for all of these parent functions, the vertex is at 0, 0. So here is our first transformation. We'll talk about translations. And I always think of these as like dance moves. And here's the formula for all functions when you're talking about translations. There's going to be some function, and there's going to be a number here with the x. So it would look like x plus h or x minus h. So the formula has a minus right here. We'll talk about that. Plus k, and that could be a plus or minus too, but the formula has a plus here. So we'll talk about what's going on there. All right, so first, the h is with the x. So this is how you think through it. This is how you memorize it. This number right here is with x. All right, and the x-axis, think about x. The x-axis is left and right. So when you see a number being added or subtracted in there with the x, that means that's going to move the parent graph left or right because the x-axis is left or right. So the number in there with the x moves the function left or right when it's added or subtracted. Okay, now let's talk about the minus. The minus is a reminder that I always tell people the x's don't play nice. So any number in that x is going to do the opposite of what you see. And that's why this formula works here. Let me explain. So if you were to put this into Desmos, you would see that f of x equals x plus 5. First of all, the parent function is f of x equals x squared, right? And see that plus 5 in there? Well, the formula is x minus h, but I don't see an x minus h. I see an x plus h. So if I were to rewrite that in the way the formula is, it's really x minus a negative 5. Okay, so what's happening is, and if you put that in a Desmos, and you should, that plus 5 is actually doing the opposite of what you see. It's actually shifting this parent function left 5. So this does the opposite of what you see. So what is happening is you have your parent function, and then when you see this plus 5 right here, it's actually going to shift it 1, 2, 3, 4, 5 to the left. So it's translated 5 units to the left. Okay? All right, over here, this is just like the formula, x minus h, so x minus 2. So if you see a minus 2, that's actually going to shift the parent function 2 to the right. So we have this parent function, and it would look like that. But g of x equals the absolute value of x minus 2 gets shifted to the right 2. All right, so my little shortcut is the x's don't play nice. So if I see x plus 5, that actually means it's going to go left 5. If I see x minus 2, that actually means it's going to shift right 2. Let's look at the k's. All right, now the k is on the outside of the function. So that's another thing to kind of understand. The way I think about this is you have this formula here, and we can think of this f of x minus h. So anything that's in there with the x, we're going to say that's inside the function. And anything that's outside that parentheses is, that plus k is outside the function. Now, if it's inside the function, it's in there with the x. So this k is outside the function. It's going to affect the y's. And the y-axis is up and down. So anything that's being added or subtracted is going to shift your function up or down. And there's a plus here. And so that means whatever you see, it's going to do what you see. So here is an example. F of x equals the absolute value of x minus 3. So that minus 3 is not in there with the x, which means it's with the y. And you see a minus 3? Okay, well, that's going to move it down 3. So the parent function is absolute value of x. Right? F of x equals absolute value of x. But when there's a minus 3 on the outside, that means it's going to shift it down 3. So that's what we would get. All right. Same thing here. G of x equals the square root of x. The parent function is the square root of x. So see the square root, that x is inside the function. There's nothing with it inside here, but the plus 4 is outside that square root of x. So it's affecting the y. So this is shifting the square root function up 4. So if we were to graph the parent function, looks like a starburst like this, and then the square root of x plus 4 would shift that same shape up 4. So no difference in the shape, just shifted up 4. Okay, now pause the video and see if you can describe the transformations on these 3 or write the function that you're given. All right, pause it and try it and then come back with me. Okay, first, describe the transformation for the following function. So we have a plus 7 in there with the x. The x's don't play nice. That's left 7. We have a minus 3. That's down 3. How'd you do on that one? All right, and in the other direction, we might give you the transformations or translations, and you have to write the new function. So it says, given f of x equals absolute value of x, write the new function, call it g of x, where f of x is shifted right 2 and up 4. So left and right is in there with the x, and they don't play nice, right? So absolute value of x, right 2, that's plus 2 to the right, but it's opposite of what you think. So it's actually x minus 2. Shifted up 4, that's outside the function. It's exactly what you think, plus 4. How'd you do on that one? All right, number 3, h of x equals x squared. Write a new function, p of x, where h of x is shifted left 5. So our parent function is x and it's being squared, right? So left 5, really, if you think about it on the axis, that's negative 5. Well, it's the opposite of what you see. So it's x plus 5. Don't forget about the square. So it maintains its U shape. And then down 3 would be minus 3. All right. So now let's move on to reflections. All right. So reflections for this transformation is all about where the understood -1 is. All right. So now reflections involve multiplying by the -1. Multiply by -1. That's what's going to cause a reflection. You can reflect over the x-axis or the y-axis. Okay, so to start, if the -1 is multiplied to the x inside the function, okay, so if that -1 is with the x, then it's actually going to reflect it over the y-axis. Okay, so here's the form. F of -x. If you see a -x, that means f of -1 times x, if you write that understood 1. And that's going to reflect the function f of x over the y-axis. Okay. Now, if the function is symmetrical about the y-axis, you won't see anything happen. All right. So, for example, describe the transformation for the following functions. So, f of x equals -x in there, quantity squared. So that's f of x equals -1 times x, quantity squared. Okay. So what's happening is you've got the parent function to the right 1, up 1, to the left 1, up 1, right? All right, now when we reflect that over the y-axis, I'm going to put some points down. Okay, if we reflect it over the y-axis, new f of x. So when I put -1 in here, okay, -1 times -1 is +1 squared, it's 1. And if I put +1 in here, -1 times +1 is -1, but you square it, and it's 1 again. So this time I have -1, 1, and 1, 1, and nothing happens. All right. And the reason that nothing is looking like happens is because the x squared function is symmetrical about the y-axis. So if you were to fold this over on the y-axis, this right branch would fold right on top of that left branch, so you can't see any reflection. All right, that happens. Sometimes the same thing's going to happen here. You have this absolute value of -x. Well, the parent function is absolute value of x. But see how it's symmetrical about the y-axis. So what's really happening is you've got this point 1, 1, and this is g of x equals -1 times x, absolute value. So we're taking this point right here, and this 1, if you multiply that 1, that x by -1, that -1, 1 is going over that x-axis, but you can't see it happening because it's a symmetrical graph. All right, so that's kind of strange. So we need some odd degreed functions, some odd functions. That means that they aren't symmetrical about the y-axis, so you can really see what's happening. So here's where you start to see something. All right, here you have f of x equals square root of -1 times x. So that -1 is in there with the x. Okay, so if I were to put some points in, let me call this g, so that we have well, we'll call it f. We'll call the transformation g, or the parent function g. So if I have x equals g of x equals the square root of x, and I put 1 in, when I square root 1, I get 1. If I put 4 in, the square root of 4 is 2. All right, now let's look at the translated function. So if I have f of x equals the square root of -1 times x, watch what'll happen. If I put 1 in, I get -1 times 1, and that's -1, and the square root of -1 doesn't exist. It's undefined. So something's happening. Let's try putting in a -1. If I put in a -1, the square root of -1 times -1 is 1, and that's 1. So I have -1, 1. All right, so if I'm going to graph this, what's going to happen is I got this parent function. We'll call that f of g of x right here. And the point 1, 1 is right here. Okay, so what's happening, this is not symmetrical about the line, the y equals x, the y-axis. So what's happening is this -1 is going to is affecting the x, right? So here's the x. So that -1 times 1 is -1, and it's going to flip that point right there to -1, 1. All right. If I have another point, 4, 2, that -1 times x is going to take that 4. -1 times 4 is -4, and it's going to flip it over here, -4, 2. So this is long-winded, but I'm getting there. All right. So what's happening is this is going to help you understand that when the -1 is in there with the x, it's actually flipping over the y-axis. It's affecting the x's, see? So when the -1 is in there with the x, it's the x's that are changing from 1 to -1, from 4 to -4. So when the x's change signs, 1 to -1, that's what causes the flip over the y-axis, see that? So 4, 2 becomes -4, 2. The x's are changing. That's why it seems like it's what you might think, what's going on? It's the y, it's the x's. Well, the x's are changing, but it causes a flip over the y-axis. Okay, so I came up with another function, a parent function that we will know pretty well soon. X cubed, it looks like this. X cubed has, when you put 1 in, you get 1. You put 0 and you get 0. If you put -1 and you cube -1, you get -1. So this is what a x cubed graph looks like. So if you have -x quantity cubed, this, remember, this point right here is going to just flip right over here over the y-axis. And this point over here on the left of the y-axis is going to flip right over here on the y-axis. And so you get that transfer, that reflection over the y-axis. All right. If the -1 is in the outside of the function, so it would look like this. -1 times f of x. So it's not in there with the x, so it must be outside the function. That's with the y. That's affecting the y. Well, if it's affecting the y coordinates, it's going to flip over the y-axis. So we can see that with this absolute value of x, that's the parent function. And then this -1 times the absolute value of x is not with the x, it's going to affect the y. So if you multiply this y by -1, you get down here at 1, -1. If you multiply this -1, 1, this y value by -1, you get -1, -1. So you can see it causes a reflection over the x-axis. So if the -1 is on the outside of the function, it's with the y's. It's affecting the y coordinates, which is going to cause a reflection over the x-axis. So this one, that -1 is outside the function, -1 times x. So it's going to take this parent function and it's going to reflect it over the x-axis. All right. So you got to memorize that, but hopefully by explaining what's going on is going to help. So -1 times the y coordinate gives you 1, -1. So changing the y coordinate to +1 to -1 reflects that over the x-axis. Okay, now we're at the toughest one, and that's vertical or stretches and shrinks. Vertical and stretches and shrinks easier than horizontal stretches and shrinks, but we can do it. All right, here's the form. A vertical stretch is going to happen when c is greater than 0. Okay, because we dealt with the -1. So we're just going to deal with this as a positive number, and it's being multiplied outside the function. Okay, so we've got multiplication and we've got outside the function. So what's happening is if you were to look at every individual y coordinate, it would mean that you're going to multiply the y's by c. So there's multiplication. All right. So what's going to happen is since the y's are being affected, it's going to cause a vertical because the y's are the up and down, right? So it causes a vertical stretch or a shrink. Okay, so let me explain. So if we graph absolute value of x with ordered pairs, so I will do -2 is 2, -1 is 1, 0 is 0, 1 is 1, 2 is 2. Okay, so if we graph all of these, we get that. All right, now over here, I'm going to just plot points for g of x. So we'll have -1. Absolute value of -1 is 1 times 2 is 2. Put in 0. Absolute value of 0 is 0. 0 times 2 is 0. Put in 1. 2 times 1 is 2. Put in 2. 2 times 2 is 4. Okay, what's going to happen is we're going to have over the same -1, but instead of going up 1, we're going to go up 2 because the y coordinate got stretched by a factor of 2. Watch again. If I go to the right one, normally right 1, up 1, but this 2 outside, I multiplied the y by 2, so I'm going to go right 1, up 2. All right, 2, 4, right 2, up 2, nope, not now. 2 times 2 is 4. And so you get this new graph that looks more narrow, but really what you want to do is just look right there. See how you went right 1, but up 2? If you pay attention to that, you'll be able to see the vertical stretch right there. And so here's how we say it. The y coordinates got stretched, okay? So the 2's on the outside is with the y's being multiplied. So the y coordinates got stretched. The y means vertical, and it got stretched. And then we say vertically stretched by a factor of 2. That word factor means multiply. So if you were asked to describe that transformation, you would say, okay, the 2 is on the outside, it's affecting the y, so it's a vertical stretch because the y's got stretched up 2, vertical stretch by a factor of 2. Okay, so that's new language. That's how you say it. All right, let's look at another one. What happens if c is a fraction? Like that. All right, so we'll graph the parent function with ordered pairs. So let's do -1, 1, 0, 0, 1, 1, 2, 4. So we know what that looks like. And I just want us to look right here at this point. That's the point 1, 1, right? But if I make ordered pairs for g of x right here, that's now going to be, all right, -1, square that, you get 1, and 1 times 1/3 is 1/3. 0, 0, +1, square it, you get 1 times 1/3 is 1/3. Let's do one more. Put in 2. 2 squared is 4. 4 times 1/3 is 4/3, or 1 1/3. All right, so when I graph this, I'm going to go over the same amount -1, but now I'm not going to go up 1, I'm going to go up 1/3. And if I go over 1, I'm going to go up 1/3. And if I go over 2, instead of going up 4, I'm only going to go up 1 1/3. And if I kept that going, you see how it's like we took this parent function x squared and put it in a trash compactor and smushed it down, which made it wider. But all you have to do is look right there at the change. So it was over 1 up 1, but now it's only over 1 up 1/3. So we say that g of x is just f of x, that it's got a vertical shrink by a factor of 1/3. Okay. So here's what's going on. If you have a number being multiplied outside the function, it's going to cause a vertical stretch or a vertical shrink. So here's the thing. If c is, I should say c is, we are assuming it's positive, greater than 1, if c is greater than 1, then there's going to be a vertical stretch. Okay? If c is a fraction, so it's positive, so if c is between 0 and 1, like 1/3 or 1/2, there's a vertical shrink. All right, let's do these. The harder of the two, which is the horizontal, and then we can practice some. Oh, before we do that, the question always arises, what happens if c is negative? All right, so let's do this really quickly. So what you want to do if you have a negative, and it's not -1, it's -4, what you want to do is you want to think of this as two transformations. So I would rewrite it this way. F of x equals -1 times 4, the square root of x. So -4 I'm going to write as -1 times 4. All right. So we've already learned what this -1 does. That -1 is going to reflect it over which axis? Well, it's not in there with the x, so it's affecting the y's. So it's reflecting over the x-axis. A little tricky, right? And then after it reflects over the x-axis, then that 4 is going to cause it to be vertically stretched by a factor of 4. So it flips first, and then it vertically stretches by a factor of 4. So that's what you do when you have a negative. All right, next thing. Horizontal stretches and shrinks. So here's the form. We're not going to deal with it negative because of what we just said here. If p is greater than 0, then if you see f of, and you see a number being multiplied in there with the x, so it's either going to be outside the function or inside the function. If that number is in there with the x, okay, notice that it's being multiplied, so it's changing x by some factor, and it's in there with the x, okay? See, way back from the beginning of the lesson, remember x's don't play nice, okay? This is what makes these the hardest, because you got to do the opposite of what you see. All right, so since it's inside the function, it's affecting the x's, so this is going to cause a horizontal stretch or a shrink. So x is horizontal, all right? So let's see what happens when we have absolute value of x. We know that is the points -1, 1, 0, 0, 1, 1, 2, 2. Okay. All right. So we got go to the right 1, up 1, left 1, up 1. That's your parent function. All right. But if we have g of x, let's do the math here. Do some points. So if I put in -1, just like I did here, what happens? The first thing to do is you multiply by 2. 2 times -1 is -2. Then the absolute value of that is 2. 0 is still going to be 0. If you put in a 1 in, 2 times 1 is 2. Absolute value of 2 is 2. Okay? So notice what is happening. Let's do one more. If I put 1/2 in, let's see that. Okay, if I put 1/2 in, 2 times 1/2 is 1, absolute value is 1. That's really what we want to see here. All right, so let me graph this. So -1, 2, it looks like it's a vertical stretch, but we're not dealing with vertical anymore. It's in there with the x, so that's why I added the point. Okay, if I put 0, 0, I stay the same. Over 1 up 2. Okay, it's right here. All right, I want to go right here. Over a half up 1. That's what we want to look at. So we're going to look right there. All right, we get this graph, but we can see the changes happening right here. So it was over 1 up 1. Now it's over a half up 1. So this is what you want to look at. Remember, the x's don't play nice. Let me explain. What's going on is, you see this, I'm going to want you to describe the transformation. This 2 is in there with the x, so this is a horizontal. Okay? All right, now think of it as a horizontal. Think of it like this. It's a horizontal. What's happening? When you think with this perspective, it's not stretching, it's shrinking. By a factor of, look at it this way. It was at y equals 1, but now it's at y equals 1/2. Right? I'm sorry. It was at x equals 1, but now it's at x equals 1/2 right there. See that? So these x coordinates are being multiplied by 1/2. Okay, it's confusing. I don't think I've ever got this through this lesson without making a little mistake there. But here's how I can remember it. This is what you're going to be asked. Describe the transformation that you see here. First thing I think, oh, there's a 2 in with the x. The x's don't play nice. Okay? It's a 2 in here with the x. So it's causing a change with the horizontal because it's in there with the x, and x is horizontal. I see a 2 that you would think that would be a stretch, but it's not. It's the opposite. It's a shrink by a factor, not of 2. What's the reciprocal of 2? Okay, reciprocal of 2 over 1 is 1 over 2. See, this is the hardest. The x's don't play nice, by a factor of 1/2. All right, that's how you think about it. So that x, it's in there with the x. Think about it this way. Since that 2 is in there helping the x doesn't have to be 1 anymore to get to 1. X has to be a half, because 2 times a half is 1. So to get that same movement up 1, you only have to go over a half because of that 2 there. I don't want you to overthink it, but I'm trying to explain it so you can remember it. So I would remember my little tips. All right. Okay, so let's just go from how I would do this, and then I'll explain further. So if I were to give you this, what you would think is, oh, that 1/4 is being multiplied to the x, so it's a horizontal. Okay, I see a 1/4, but the x's don't play nice. So it's actually a factor of the reciprocal of 1/4 is 4. Okay, 1/4, you'd think it'd be a shrink, but it's a stretch. Okay, let's verify it. Let's graph it. So we have x squared, where we have 1, 1, 2, 4, 3, 9. All right, so we'll graph it. So right 1, up 1, right 2, up 4. Right, and the same thing on the left, because the x squared is a symmetrical graph. All right. Now let's come over here, and I need to just be clever about the points that I pick, right? So I want to demonstrate, what's it going to take for the y to get to be 1? Well, if I put, when x is 4, 1/4 times 4 is 1. 1 squared is 1. What's it going to take for me to get 4? Well, I would need this to be a 2 in here. So if I let x be 8, 1/4 times 8 is 2. 2 squared is 4. All right, one more. If I need a 3 in here, So I can get 9. What's it going to take? Well, that would be 12. 12 times 1/4 is 3. 3 squared is 9. So see how it's actually, that 1/4 is actually making the x's get bigger. So 1, 2, 3, 4 up 1, left 4, up 1. And you can see it's causing a horizontal, as I said, stretch by a factor not of 1/4, but of 4. So try to remember the x's just don't play nice. Okay, so to sum up, here's the form again. If p is greater than 0, if p is in there with the x, if p is greater than 1, then there's going to be a horizontal shrink by a factor of the reciprocal of p. But if p is a fraction smaller than 1, then there's going to be a horizontal stretch by a factor of the reciprocal of p. All right, again, what if p is negative? In this case, you just want to rewrite that as f of x equals the square root of -1 times 4x. So this -1 is going to cause the reflection over the y-axis. So you take care of that, and then that 4 is with the x. So it's going to be dealing with a horizontal because it's with the x. Okay, 4. There it is. Opposite of what you see, it's doing something by the reciprocal of 4 is 1/4. See, it's not a stretch, it's a shrink. So we've got two things happening. You have a reflection over the y-axis, and then you have a horizontal shrink by a factor of 1/4. All right, this is a long lesson, but before we move on, I want to just see if we can practice one time. So if you flip over, you'll see some exercises. Let's just do one at one here. So let's try number 2. All right, pause the video and see if you can describe the transformations for the following functions. All right, now you want to make sure you write it down in order of PEMDAS. So try that. Okay, I'm going to do this. First thing I'm going to do is write this -1 times the square root of 2x plus 4. So I said do it in order of PEMDAS. So what that means is PEMDAS says first you got to look in the parentheses. So if I look in the parentheses, this is a grouping symbol. This square root acts like a grouping symbol. So the first thing I want to talk about is what this 2 is doing to my x. Okay. So it's in there with the x multiplied, so it's a horizontal. All right. It's 2 is greater than 1, so it's not a stretch. X's don't play nice. It's a shrink by a factor of 1/2. That's how you write it. So that would be the first statement. The order matters. All right. So we did the grouping. Next thing, there's no exponents. Multiply, divide. Do we have multiplication? Yeah, we have this -1. So the next thing we would write down is what that -1 does. Well, that -1 is outside the function. Square root of x is the inside, -1 outside, so that's going to cause a reflection. It's changing the y's, so it reflects over the x-axis. Because when the y's change, 1, 1, 1, -1, that reflects over the x-axis. All right, next in order of operations, you have addition, subtraction. So there's the plus 4. So that would be shifts up 4. Okay, so I just wanted to do one where we talked about order. The order will matter. So you have to use the PEMDAS rules to get the order right. Okay, there's one more thing that we could ask you, and that has to do with these graphs here. All right. What do you do when you're given a graph? The directions say this. This is some mystery function. I don't actually know what the function is. And for each graph, use what we've learned about shifts, reflections, and stretches to sketch the graph of the indicated function on the same plane. So this mystery function is f of x, but we want to create f of x minus 3 plus 1. Well, you just want to do the same things, except I like to do ordered pairs. So the rules are going to be the same, but we can write ordered pairs and just actually do what we know is happening to each ordered pair. So I'm going to write down these ordered pairs, and that's what I would do if I were you. 1, 2, 3, 4, -4, 0, and then -3, 1, 2, 3, oops, 1, 2, 3, -3, 2, and then -1, -2, and then 0, 0. Okay, so that's your first go at it. You write down the ordered pairs. Then you use order of operation and say, okay, what's happening first? Well, you see the x minus 3? Remember, the x's don't play nice. So what you're going to have to do is you're going to have to add 3 to your x's, right, and create new ordered pairs. So if we just add 3, we get -1, 0. -1 plus 3 is 2. 0 plus 3 is 3. And the y's don't change. All right. So that is going to cause the shift right 3. So we did that. All right. The next thing that's happened is you have a 1 being added outside the function. So remember, that's outside. So that's going to affect the y's. So and they play nice, so you're going to just add 1 to the y's. So y plus 1. So my new ordered pairs, the x's, they don't change now. And I'm going to add 1 to the y's. Then that's it. Those are the ordered pairs you would go and graph. So -1, 1, 0, 3, 2, -1, and 3, 1 are my new points. And then you want to just make sure you keep the shape the same. So it started here. We're going to start here, go down, and then around. And that is the transformation. All right, now the second one, definitely want to do this one with you. So this is really tricky. We've written it differently. So the first thing you want to do is rearrange it so that you can tell that this 2 is positive and this f of x is really a minus. So I'm going to rewrite it as -1 times f of x. That 2 is positive plus 2. If you don't do that, you'll tend to forget what to do first. All right, so again, we start out by writing down the ordered pairs. All right, so we have -3, 0, and you don't have to write, just wherever there's changes, the -2, 1, 2, 3, 4, -2, -4, and then goes over 1 up 2, and then 5, 0. Okay, now we have to create new ordered pairs in the right order according to PEMDAS. All right, so the first thing, PEMDAS, parentheses, there's no parentheses, exponent, there's no exponents, but there is multiplication. So the first thing we have to do is deal with that -1. So that -1 isn't in there with the x, so that means it's multiplying by the y to the y, so -1 times y. So let's write down the x coordinates so they don't change and multiply the y's by -1. 0 times -1 is still 0. -4 times -1 is 4. 2 times -1 is -2, and then you still have 0. Okay, so we did that. Now plus 2, that plus 2 is not in there with the x, it's in there with, it's the y, so it's outside functions with the y, so we're just going to add 2 to the y. So we'll copy down these x's, and here's where the order matters a great deal, because both of these are affecting the y's. You have to do the -1 first and then add 2, or you'll get the wrong answer. So that becomes 0 plus 2 is 2. 4 plus 2 is 6. -2 plus 2 is 0. 0 plus 2 is 2. So now, those are the new order pairs with the transformations applied. And you get -3, 2, -2, 6, 2, 3, 4, 5, 6, 1, 0, and 1, 2, 3, 4, 5, 2. Okay, now You kind of have to know where this is going. You can see that the flip is happening over the x-axis, so that makes sense. All right, and now I just want to say I highly recommend you do this because sometimes people make mistakes, and if you don't have any work and your graph is off, I can't tell what you did, where you went wrong. But here at least I can tell where you went wrong and you can get partial credit. All right, I'm going to pause the video. You try the next one and then check. All right, so I just did it and I got PEMDAS rules. I had to do inside the parentheses. -3 is with the x, so it's the opposite. I needed to add 3 to the x's. And then 1 plus, that's a translation, but it's affecting the y, so I added 1 to the y's. All right, keep practicing. You've got all of these exercises to do. I'm going to stop the video here, but there is a key located somewhere, so try it and check the key.